number 44. So we jump straight into a factor tree. We'll write that right below 44. What times what is 44? Well, I think 11 times 4 is 44. Now, 11 I can't really break out anymore because all I would have under there would be 1 times 11. That's all I can come up with to make 11, so I'm not going to do that. It doesn't give us any new information. But the 4, you can write it as 2 times 2. Now the 2's you really can't break up either because that would just be 1 times 2 underneath each one of those. So this is as far as I want to take the tree. And then I want to recall, or have you recall, that when we're finding factors of a number, the number 1 is always a factor because 1 times 44 is 44. And we know that 44 is going to go at the end of the list. Let's write down everything in between. We know the number 2 is going to be a factor. We know the number 4 is going to be a factor. Now we could just go ahead and write, I forgot 11 here. 11 is also a factor, so let's write that down, 11. And let's think through, what else could we have? So we've written the number 1 as a factor. We know that's for everything. 2, 4, and 11, we wrote those down. So we have everything in the tree. Now we have to find extra factors by multiplying across. This is one branch. This is another branch. 11 times 2. 11 times 2 is 22. So 22 is not in my list. It has to be a factor. Of course, 11 times this 2 gives me the same thing. There's nothing else to do other than 11 times 4. And I'm going to put then 44 at the end. I knew that was going to be a factor anyway. So the factors of 44 are 1, 2, 4, 11, 22, and 44. A prime number would be a number that has only the factors itself and the number 1, but this number has lots of other factors, so we call this composite. Right? And we circle that as our answer. Now, let's go through the factors. This is a factor because 1 times 44 is 44. This is a factor because 2 times 22 is 44. This is a factor because 4 times 11 is 44. This is a factor because 11 times 4 is 44. This is a factor because 2 times 22 is 44. And of course, this is a factor because 44 times 1 is 44. All right, that was a good intermediate level problem. Here is going to be kind of a monster problem. This is one of the monsters I told you about. It doesn't seem like it would be so hard, but it gives a lot of factors. So let's go to a new board and give us lots of space. Let's take a look at the factors of the number 60. Doesn't look like a huge number, but it's going to give us a lot of factors. So what you would have to do manually is you'd have to go 1 and 2, then 3, then 4 and 5, and you'd have to look for math facts or multiplication facts to multiply to give us 60, and you have to go all the way up to the number 60 and consider all of those numbers. A much easier way is to write a factor tree. So let's take a look. Here's 60. You can put anything you want under here. Let's just do the easiest thing. 10 times 6 is 60. So let's put a 10 times 6 is 60. Now under this side, I can further break this down into anything I want. I'm going to pick 2 times 5. That's 10. And then over here, 6, I can write that as 2 times 3. Now the tree is basically done. I could break the 2 further, but it would be just 1 times 2. That's nothing new. I could go and break this into 5 times 1. 1 times 2, 1 times 3, but all I would do is have extra 2's and 5's and 3's down there. That's not going to add anything. So I'm in a position now where I can start to write the factors down. So I'm going to start, I'll just do it like this. We'll write the number 1. That's a factor, right? Look in my tree and 1's a factor of all numbers. Look in my tree and see what else I find. 2 is a factor. 3 is a factor, right? 3 is a factor. Now, here's where it gets a little bit tricky. If I was not very careful, then what I would do is say, okay, I did 2 and then 3. I'm going to write 5, 6, and then 10. And that's fine. Those are all correct. But the problem is, actually, if you look across branches, this is a branch of the tree, and this whole thing is a branch of the tree. I can multiply any numbers across. 2 times 2 is 4. So 4 is also a factor. So I don't want to skip over that. I'm going to write the number 4 down. That's a factor too, right? That's a factor too. The next one after 4 is 5. That's in my tree, so that's got to be a factor. And then 6 is in my tree, so I'm going to write that down next. That's a factor. And then you think 7, 8, 9, 10, and so on. None of those are factors. Then 10 is going to be a factor. And then you start thinking, have I written everything down in the tree? I have written 2, I've written 3, I've written the 4 coming from there, I've written 5 and 6. So then I start thinking of anything else that can cross multiply from branch to branch. Well, I have a 6 times a 2. That's 12. So 12 is a factor, right? So I have, then I have 3 times 2 is 6. That's already in there. 5 times 2 is 10. That's already in there. 6 times 5 is 30. That's going to be in there, but I think we're going to wait to write it down. What else do you have? We did 2 times 2 is 4. What about this? 5 times 3, that's 15. So that's a factor. That can come after 12 there. And then what else? We have 10 times 2. That's 20. That's a factor, right? 10 times 2. Then we have 10 times 3. That's 30. That's another factor. And I think that's actually it. 10 times 6 is going to be the last factor, which of course we already know that 60 is a factor. So what you have to do when you have a tree that's big like this is make sure you're multiplying everything across the branches. So let's go through it one more time. 1 is a factor, 2 is a factor, 3 is a factor, right? Now 5, 6, and 10 we could write it down, but then we see right away that 4 is a factor, right? So we have 4, then 5, then 6, and then we start multiplying through and just see what else we have. So we have 3 times 2 is 6, that's already in the tree. 3 times 5 is 15, that's already in there. 5 times 2 is 10, that's already in there. We wrote the 10 down there. Then we have 6 times 2 is 12, that's in there. Then 6 times 5 is 30, that's in there. Then 10 times 2 is 20, that's in there. Then 10 times 3 is 30, that's in there. Then 10 times 6 is 60, that's in there. So literally I've taken every single number in one branch, multiplied it by every other number in the other branch. Together I will get all of the factors of this thing. Now look at how many factors there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factors. It didn't take that long with the tree, but if you had to think about all of these, I would probably miss some of these factors up here because I wouldn't really be thinking about 20 and 30 as factors. So let's go through, first of all, and write down, we know this is composite, of course, because it's so many factors. Let's go through and make sure we understand. 1 times 60 is 60, so that's a factor. This is a factor because 2 times 30. 3 times 20 is this guy. That's a factor. Then we have 4 times 15. 4 times 15 is actually a factor. 4 times 15 is probably one I would forget when I was doing this. Personally, it would be one that I would forget. But if you multiply 4 times 15 out, it's going to come out to 60. Then 5 times 12 is 60. That comes from multiplication tables. Then 6 times 10 is 60, right? And then you start going the other way. You have 12 times 5, and then 15 times 4, and then 20 times 3, and then 30 times 2, and then 60 times 1. So they're kind of mirror images. The ones in the beginning multiply with the ones at the end. That's kind of what happens when you write them all in order. So the best advice I can give you is to write the first factor down as a 1 and start writing numbers down out of your tree. Cross multiply everything, create a list, and then write them in order. And that's basically how you have to do it. And it's as much of a pain as it is, it's actually easier to do it this way than to, start thinking about multiplication tables. All right, let's take a look at problem 3. Problem number 3. Let's look at the factors of 79. The factors of 79. Let's build a tree. What times what is 79? All I can think of is 1 times 79. I can't think of anything else. So the factors of 79 are 1 and 79. They multiply to give us this, and because of that, it's prime. Pretty simple little problem, but, still trying to show you and work everything out so you see where everything's coming from. All right, let's go to a fresh board. This is going to be another monster problem. Let's look at the factors of 84. Factors of 84. All right, it's a big number. It's going to yield a lot of factors. So what we do is we put 84 down here. And you think, what times what is 84? If you think back to your multiplication tables, 7 times 12 is 84. Now, you can pick anything you want. I don't care, but 7 times 12 works, so we're going to go with that. Now, 7, I can write it as 1 times 7. So it's not going to give me anything further, so I'm going to leave that alone. This can be 3 times 4. This can be 2 times 2. I can't break 3 up anymore, and I can't break 2 up anymore, so the tree is now done. So then I go over here and start writing factors. I know that the number 1 is a factor of every single number. So that's a factor. Then I start reading off of my tree. I see that 2 is a factor. I see that 3 is a factor. I see that 4 is a factor. And I see 7 is a factor. So what we have here is this is a branch, but notice this branch is this way and this branch is this way. So we can multiply this times anything over there, but also anything in different branches like this is a different branch than this. So we can multiply 3 times 2, and that would give us 6, which is another factor. So we can put 6 right there. right? After 6 would come 7. That's straight out of our tree, so we'll write that down. And then we just want to make sure we don't miss anything, but we can see that 12 is in here, so we can write 12 down as a factor. And then we can multiply 7 times 2 is 14. That's a factor. And then we have 7 times 3 is 21. That's a factor. And then we have 7 times 4 is 28. That's a factor. All right. And then what else do we have here? Now the next one in the list is a little bit tricky because we already did 7 times 4 is 28, and we already did 7 times 3 is 21. We already did 7 times 2 is 14. That's all good. But we also know that 6 is a factor because 3 times 2 is 6. So what you can also do is say, well, this is in a branch, and we can multiply it times the 6 that comes from multiplying this as a factor. So 7 times 6 means 42 is a factor. So we can write 42. That's also a factor too. So you multiply branch to branch, but also if your branches keep forking on one side like they do here, then you can say, well, this is 6, and then this 6 multiplied by this is also a factor. It's because these are in different branches. This is one branch and this is another, so this is another branch. So that could be 6 times 7 is 42. And the last one we have on our list is 84 because the number itself is always a factor. Of course, 7 times 12 is 84. So the factors that we have found are 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. 1 is a number that just comes because every number has a factor of 1. Then we have 2, 3, and 4 straight out of the table. 6 comes about because this is a different branch than this. 3 times 2 is 6, so that comes there. Then we have 7 from there. 12 comes from this guy. And then we start cross-multiplying. The 7 times 3 is 21. 7 times 2 is 14. That comes next. 7 times 3 is 21. 7 times 4 is 28. So we pretty much covered it all, but we have one more combination because these are in different branches. The 3 times 2 is 6, and the 6 times 7 is 42, and that goes there. And then once we have all that, we've cross-multiplied everything. So 84 is, of course, the last number in the list. Of course, you can multiply those for 84 as well. Now, let me guess. Is it prime or composite? Of course, it's composite. All right, now again, this is our answer. Writing this factor tree looks very confusing, but you know what's even more confusing? Trying to think of all the numbers between 1 and 84 and going through every one and saying, okay, does this times this equals this, and this times this equals this? It's very hard to do. We know this is a factor because 1 times 84 is 84. This is a factor because 2 times 42 is 84. This is a factor because 3 times 28 is 84. This is a factor because 4 times 21 is 84. And then we could go through the other direction and look at all the other ones and see exactly the same thing is the case. So when the numbers are big, it just gets difficult. There's lots of things to consider, lots of branches of the tree, and it's very easy to get some of the factors but not catch all of them. That's the bottom line. All right, the next one we're going to work on is not quite as hard, the factors of the number 72, factors of 72. So let's try to write a factor tree for 72. So what times what is 72? We know that 8 times 9 is 72. And 8 we know we can write is 2 times 4. And this 4 we know we can write is 2 times 2. This guy, 9, can be written as 3 times 3. And I'm basically done. I don't want to go any farther because all I will get is 1 times the number itself for those. So then I'm going to start writing down the factors. The number 1 is a factor of every number. And then I see 2 is written in my list, so that's a factor. I see 3 is in my list, that's definitely a factor. 4 is in my tree, that is definitely in a factor. 5 is not in there, but then I start thinking 6 and 7 and so on. 8 and 9 are all going to be in there, but then I don't want to skip over anything, so I say, well, I have a 3 in this branch and a 2 in this branch. 3 times 2 is 6. So 6 is going to be in there. And 7's not in there. There's no way to multiply across and get 7. But 8 and 9 are all in there. So put 8 in there and put 9 in there. All right. So at this point, I've written everything in the tree. I've written the 2 down, the 3 down, the 4 down, the 8, and the 9. And I've already multiplied 3 times 2 to get 6. So what I have to do is start multiplying every other combination. So I've already done 3 times 2 is 6. What about 3 times 4? That is 12. So that's going to be in my list. I haven't put that there yet. So I've multiplied 3 times 4 is 12. 3 times 2, 3 times 4, I've already done that. So then let me multiply this. 8 times 3 is 24. That's going to definitely be in my list. But let's think about any other combinations. I have the 9 over here times 2. 9 times 2 is 18, so that's going to be in the list. I have 8 times 3. 8 times 3 is 24. That's going to be in my list. And then I have 9 times 4. That's going to be 36. That's going to be in my list. And then I think that's all I can do, because if basically what you have to do is pick 8 and say, okay, 8 times 3 is 24. That's in there. 8 times, well, I'm already done with this guy. I'll go 9 times 2, 18. That's in my list. 9 times 4, 36. That's in my list. 9 times 2, 18. That's in my list. There's no other way to cross multiply it. I've cross multiplied everything and I've written everything down. So the only other number remaining is just 72, the number itself. 8 times 9 being 72. So again, one more time from the top. Every number has 1 as a prime. 1 as a factor. Then I write 2 and then 3 and then 4 straight out of my factor tree. And then 6 comes because of 2 times 3. And then 8 comes because it's written right here. 9 comes because it's written right here. And then I just got to start cross multiplying. I know that the 4 times 3 is going to give me 12, so that's a number that fits in there. And then 8 times 3 is 24, that fits right there. And then 9 times 4 is 36, that's in there. The 18 is already in there from 9 times 2. I guess I might have skipped over that guy. And then the last guy is 72. So basically you have to go through the tree and cross multiply every possible way and get any other numbers that are listed there, write them down in your factoring. So what we have is 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. And all of these numbers come from multiplying across this tree like this. And of course, this is a composite number. Composite number. All right, that was 72. I told you it would get a little bit tricky. Let's take a look at something not quite as tricky. Let's take a look at the factors of 97. Factors of 97. 97 as a factor tree. What times what is 97? All I can think of is 1 times 97. So the only factors are going to be 1 and 97, and it's going to be prime. Right? Makes sense, because those are the only factors that really are there. All right. Only 2 more problems. Let's take a look at the factors of 64. Factors of 64. All right, so factor tree. We have a 64. What times what is 64? I'm going to write that as 8 times 8. That's 64. 8 can be written as 2 times 4. This 8 can be written as 2 times 4. This 4 can be written as 2 times 2, and this 4 can be written as 2 times 2. So I'm done, because I can't break the 2's up any further, because all I'll have is 1 times 2, and that doesn't add anything new. So the next thing I need to do is start writing down my factors. All numbers have a factor of 1. Now, of course, 2 is written directly in my tree, so that's a factor. 4 is written directly in my tree, so that's a factor. 8 is written directly in my tree. That's a factor. And so I've written everything down. 2, and then 4, and then 8. So all I have to do now is start cross-multiplying. 2 times 2 is 4. That's already in my tree. 4 times 2 is 8. That's already in my tree. So what about 8 times 2? That's going to be 16, so I need to write that down. 8 times 2 is 16. What about 8 times 4? And this is another branch. 8 times 4 is 32. So I need to write that one down. And then there's really nothing else I can multiply across. So the only other thing is the number itself, which is 64. So I have 1, 2, 4, 8, 16, 32, 64. And of course, it's composite. All right, those are the factors. All right, I think we only have one more problem. The question is it going to be a long one or a short one? It's going to be a pretty long one. So let's go find some board space. Yeah, we have plenty of space over here. We're going to go do our last problem over here. We're going to need some space. Let's take a look at the factors of 90. Factors of 90. All right, so let's go and do a factor tree right here, 90. What times what is 90? You can pick anything you want. I'm going to put 9 times 10 is 90. Now for 9, I'm going to go with 3 times 3 is 9. For 10, I'm going to go 2 times 5. And actually, that's the extent of it, because if I break down the 3's, it's going to be 1 times 3. This will be 1 times 2 and 1 times 5. It doesn't give me any new number, so I'm done with the factor tree. All right, so let's go up here and start writing factors. 90 is just like all numbers. It has a factor that's a 1. Now I start reading off my tree. 2 is a factor, so I write that down. 3 is a factor, so I write that down. 5 is a factor. So I write that down. Now I know that 9 and 10 are going to be factors. I can write them down, and then I could go back and look for anything else. But I start thinking about it and realizing I have a 2 in this branch over here and a 3 in this branch over here. So 2 times 3 is 6. So that would be really the next one in the sequence there, 6. After 6 is going to come 9 and 10, because 7 and 8 are not factors. There's no way I'm going to multiply any of these numbers together to get 7 or 8. So 9 is going to be a factor. And then 10 is going to be a factor. So I think I've written everything down in here. I've got 1, that's every number has that, 2, 3, 5. I multiplied this to get 6, and then 9 and 10. So I've written everything down. So now it's a time to go and start multiplying through everything cross that I can. I've already done 2 times 3 is 6. What about 3 times 5? I got a 3 here and a 5 here, so that's 15. So 15 is a factor. So I've already done the 3 times 2 is 6. I've already done the 3 times 5 is 15. So now I've got to go up a level and say, what about 9 times 2? Well, that's 18. That has to go in there. 9 times 5 is 45. That's going to come later. So let me hold on to that for later. 10 times 3 is 30. That's going to go in here. And then after that, 9 times 2 is 18. I already have there. 9 times 5 is 45. That's going to go in there. And then I start thinking, I think I've pretty much got them all, because I've done 2 times 3 is 6, that's in there. 5 times 3 is 15, that's in there. 9 times 2 is 18, that's in there. 9 times 5 is 45, that's in there. 10 times 3 is 30, that's in there. I don't think there's anything else I can multiply. So the last number that's possible is just 90, the number itself, which is, again, 9 times 10. So I have 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45, 90. And of course, this is what we call composite number. Right? Lots and lots of factors. So again, 1 times 90 makes 90, so they're factors. 2 times 45 is 90, so they're factors. 3 times 30 is 90, so they're factors. 5 times 18, believe it or not, is 90, so they're factors. 6 times 15 makes 90, so those are factors. 9 times 10, and then we can go the other way and look at the other one. So they're all there, and you kind of go at the end through like this, multiplying and making sure that they're all going to give you 90, which is what you're trying to do. So you might say, why have we spent so much time on factors? It turns out that factors is a really important thing. It's more important a little bit later when we get to other things called algebra and other parts of math where we have to break things down into smaller pieces. A lot of times when you solve a problem, the way you solve it is you break it down. So by taking these numbers like 90 and breaking it down into all the smaller numbers that can multiply together, we actually use that idea to break down other problems later on and make them easier to solve. That's why we learn it now. But really right now, all I want you to know is what a factor is, how to find the factors, how to make this factor tree, and how do you know if a number is prime or composite. And that wraps up not only this topic, but this whole batch of lessons on multiplication. And then of course we've done the word problems, and we've done the primes and the composites and the factors. Tremendous amount of stuff. We've done so much here. I'd like you to solve all of these yourself. Make sure you're getting good practice, good confidence in your skills. And then follow me on to the next set of lessons. We'll continue building your skills through the sequence, step by step. Learn anything at mathandscience.com.